Okay, we've inversed or reversed the rows of the y equals x squared table to get a table that we're going to use to create the y equals square root of x function. However, when we graphed the points on this table, we found that the graph isn't the graph of a function. That each of the x values in our table, in fact, gave us two y values. And clearly, the curve through these points will not satisfy a vertical line test at any point except maybe the origin. What I'm going to do then is I'm going to trace out part of the graph in blue and another part in green. Now the green part alone forms a perfectly good function. If we just throw away the blue part and just concentrate on the green part, it does satisfy a vertical line test. For every value of x, there's just one value on the green part of the curve, one value of y corresponding to the green part of the curve. Similarly, I could throw away the green part and I'd have a perfectly good function from the blue part. Every x value gives you exactly 1 point on the blue branch of this graph. Well, by convention, we're going to say that the square root of any number that gives us a real number, and we'll of course end up looking at complex numbers lately, but for any number that gives us a real valued square root, the square root is going to be positive, except when x is 0, in which case the square root is 0. So we're going to kind of throw away the blue branch of the graph and just accept the green branch. And this means that we're going to throw away the points that we obtained here. We're going to throw away, in other words, all the points where the y value is negative, because that's exactly the 3 points that gave us this part of the curve, along with the point at the origin, which of course works just fine for the function that we want. So I'm going to cross this out, I'm going to cross this out, I'm going to cross this out, I'm going to get rid of this, and I'm going to say that, okay, here is the graph, or the part of the table that corresponds to the square root function. So we throw out the blue branch of the graph. This leaves the green branch. Which is the graph of y equals square root of x for 0 less than or equal to x less than or equal to 2. So this is how we construct the graph, our basic graph, our most fundamental graph of the square root function by inversing the x squared function. Now, of course, we could use arithmetic. We can easily find that the square root of 4 is 2, the square root of 1 is 1, and with a little bit of thinking, the square root of 1/4 is 1/2. And the square root of 0 is 0. So we could get these values, but I wanted to show how this graph is obtained from this table. There are many insights into this process, particularly the insight associated with what we call inverse functions. Very important class of functions.